Hi, Math 12. So now what we'll do is we'll look at the last section of Unit 1, which is on inverses. So basically, an inverse of a relation is where you switch the x and y coordinates with the original to the inverse. And what will happen after you do this is you'll have a line of reflection along y equals x. So that's what you see over here in this example. Okay, so this this minus 1 here, this is what we mean by the inverse. Okay, so there's the inverse, and there's your original fx. Okay, so let's look at a couple of examples. First one here, so there's your original function, and so what we would want to do is we'd want to find some coordinates. Okay, so let's take this one here. That is 6. Let's put that over here. 6 and negative 2. I guess we'll call this fx. Okay, another one we've got here at 2 and negative 1. And then let's see, there's one other one right here at negative 1, 1. Okay, so there's your original fx function. So now what you basically do is, to get the inverse, you switch these. So 6 negative 2 is going to become negative 2, 6. Okay, so we're switching the x and y. 2, 1 becomes negative 1 and 2, and then negative 1, 1 becomes 1 and negative 1. Okay, and so now we can put points there. So 1, negative 1 would be right here. And then we've got negative 1 and 2. And then negative 2 and 6. That would be around here somewhere. Okay, so your function's going to look like that. Okay, and in terms of actually, let me just do that again here. See here, that didn't look very good. It'll sort of look like. Oops. Okay, so I'm not doing a. Let me just do that again here. Okay, it's a little bit messy, but I'm trying to show the invariant point is going to be right here at the middle. Okay, 0, 0. They're both going to, even though it doesn't show up that good on the one I've drawn here, that would be your invariant point. Okay, 0, 0. Okay, and now to determine whether both of these are functions, so remember, if something's a function, it has to pass the vertical line test, which basically means that if you draw a vertical line, you should only be able to get one value. So both of these would be yes. Okay, so they're both functions. If you have something like like this, that would fail the vertical line test, because if you went down here, you'd get 2 points. Okay. And then the domain of the range. So it's a little bit hard to tell with the original function, because you don't know if x equals minus 2 is an asymptote. So if that were the case, then it would be the function for the domain would be greater than negative 2, and then for y it'd be all real values. So that's assuming this is an asymptote, okay, but it's a little bit hard to tell. If it keeps going left, then it'd be all real numbers. And for the inverse, if it continues to go down and up, it's all real values, and if it continues to go left and right, it's all real values as well. Okay, let's look at this one here. So we got x plus 2 squared. And so we want to graph this function here. So you can use a table of values for the regular function. Okay, so let's use let's use 0. So if x is 0, y is going to be 4. Okay, let's use negative 2. If x is negative 2, y is going to be 0. Let's use 2. If that's 2, that's going to be 16. That's going to be a little bit hard to graph, so let's try a different point here. Let's use 1, that's going to be 9. Okay, so 0, 4, negative 2, 0, and 1 is going to be 9. Well, let's just do another one here just so I got a better image. Let's do negative 3. Negative 3 is going to be negative 3 is going to be 1. Okay, so that's going to be here. So it gives us a, let's do one more point here. Negative 4 is going to be 4. Okay, so there's your fx function, okay, the original. Now I did a lot of points here because I was trying to get a good idea of what it's going to look like. The ones I'll use as far as the mapping goes, I'll use 0, 4, and I'll use negative 2, 0, and I'll use negative 4, 4. Okay, so I'll use these three because that gave me a good idea of what the parabola looks like. So let's look at the inverse now. So the inverse, so we'll call that f of negative 1x. Okay, so that means inverse. And so now what we'll do is we'll just swap these. So this will be 4, 0. This will be 0, negative 2. And then this one here will be 4, minus 4. Okay, and let's draw that out. So we got 0, negative 2. And then we've got 4, 0. And then 4, negative 4. Okay, so there's your f of minus 1x. Okay, your inverse. Okay, so there's the function. Now it says, is the inverse a function? So the answer here is going to be no, because of the vertical line test. So if you put a vertical line through here, you hit 2 points. So that's why it's not a function. We graph the inverse. Describe how the domain of fx could be restricted so that the inverse is a function. So basically, what question C is saying, in order for the inverse to be a function, then you either have to keep only the top part of the parabola or the bottom part. You can't have both. So for example, if you said, if you wanted, remember your mirror line here is y equals x, right? So there's your mirror line. Okay. So if we wanted, let's say we just wanted the top part here of the inverse, that means then we'd only want this part of the original. Okay, so if that's the case, then the original here, your domain would have to be set so that x is greater than or equal to -2, because then that means the left part wouldn't exist, and if the left part doesn't exist, that means the bottom part here won't exist either, and then those two will both be functions. The opposite is also true. If you take the original and just say x is less than or equal to -2, then you keep the left part, and then the bottom part of the inverse would be a function. Okay, so that's what they mean by that type of question. Okay, let's look at example 3. Okay, so this one's a little bit different. They want us to graph this again, but first off, they want us to figure out how to come up with the other equation. So this is your normal function here, x plus 9 over 3. So when we want to, so let's rewrite this in terms of y. Okay, so let's just call this y equals x plus 9 over 3. And so if we want to make this an inverse, what you're doing is you're switching x and y. So this then becomes x equals y plus 9 over 3. And then what we want to do is rewrite this in terms of y. So we'll multiply both sides by 3. So we get 3x equals y plus 9. And so this is going to be y equals 3x minus 9. Okay, and so this is your inverse. Okay, so now what we can do is we can graph this. Okay, so what you should remember here is this is just a linear graph, 3x plus 3x minus 9. So that just means that minus 9 is your y-intercept, and your slope is 3. So that means you go up 3, and you go to the right one. Okay, so here's our, so this is our inverse. And then the original one here, we've got x plus 9 over 3. So the original function here we can change that to, this is the same thing as saying 1/3 x plus 3. So again, that's just a straight line. So here your y-intercept is going to be 3. And then your slope is 1 over 3. So that means you go up 1 and you go to the right 3. Okay, and this is your regular function. Okay, so I'll stop there, and, then, in terms of it saying verify, so again, what you wanna show is basically your mirror line for an inverse is y equals x. Okay, so there's your y equals x. So just like when we do a reflection, in order to have a reflection, you need a mirror line. So y equals x is a mirror line when you're talking about inverse. They have to reflect upon that line. Okay, so pretend that's the mirror that you're holding up, that's reflecting the object in its image. Okay, so I'll stop here. So that finishes the unit 1. Okay, and so I'll give you some questions to work on for this part.